Good to go. Okay. Yeah, and as mentioned, I think we'll just go ahead and talk a little bit about this for half an hour, 40 minutes, and then we can jump in and have some questions and answers. If you have questions as terribly confusing as we go along, please feel free to ask me to clarify things.
You can also put questions in the chat, and I'll be looking at those.
Yeah, that'd be great. So just a little bit about RMI for any of you who would like to know more. We have been around for about 40 years and have also gone by Rocky Mountain Institute. So a lot of people know that, but a couple of years ago, we sort of had a rebranding. So we're just RMI. And we've actually grown a lot since I've been there about 17 years and started out in kind of around the kitchen table of Avery & Lovins, and we've grown. There was about 40 people when I started, and now we're almost 700. A lot of different areas. We work in mobility, we work in electricity, as well as buildings. We have offices in New Delhi, India, Beijing, New York. We don't have an Atlanta office, but I'm sure we have some people down there. And yeah, we've been doing a lot of work, and we continue to try and do as much as we can to sort of ensure that we're facilitating the energy transition in alignment with, IPCC climate goals, to have a what we can imagine as a prosperous, secure, verdant, enjoyable, equitable future for all of us. So it's a big task, and I appreciate everybody being interested and excited about this. And we'll talk a little bit about kind of the role of buildings here in this. And we have a fairly concise way of thinking about this, and hopefully this makes sense to all of you. But we call this the recipe for low carbon buildings, carbon-free buildings. And it combines both sort of the construction, the low embodied carbon side, as well as the operational side. And this is not a secret that those are both really important. And the low embodied carbon is kind of right up front here at the beginning. In addition to that, we have to have efficiency, electrification. We think that what's really critical, that buildings don't operate as islands, but they actually are part of a larger network, working with utilities, working with all of the infrastructure that we have. So this idea of demand flexibility is critical. Obviously, we need to increase the amount of clean, renewable energy, and then refrigerants are in there too as a critical part. And sometimes people think about low embodied carbon as including refrigerants, since they are materials. Some people think of them more operationally. However you want to categorize them, they're critical. We have to kind of think about that. Add all these things together, and we really do get to that goal of having healthy, resilient, carbon-free buildings, which can be a foundation for the future. And I think I'm assuming that as a COTE group, we're a lot of architects in this group, and this is really a call to the opportunity to make buildings a really strong part of the solution. So I'm sure you've heard that before. I'm reinforcing it. It's probably one of the most exciting things as a designer that we can get engaged in now. To show how positive an impact we can have. At the bottom of this slide, contextual factors. We also have to think about industrial issues, transportation and mobility, as well as the grid. So those things surround our buildings and are things for us to connect to and integrate in the most benign and kind of optimal way. So this is kind of the way we think about it. And today, what we're really going to talk about is this piece up front, the low embodied carbon materials. As you may know, buildings have about 40% of global emissions. It's a huge piece of that. And construction materials are somewhere between 9 and 11%, depending on how you count it. But it's a big chunk of this overall building's impact, and one which we have a lot of control over. So what is embodied carbon? It's really the whole kind of chain of how materials are used, from the very beginning, extraction and manufacturing of materials, to the end of life, where we have the disposal and recycling. So in this slide, all of those items in yellow are considered parts of the life cycle that are where we're thinking about the embodied carbon, and the blue is the operational area where we're actually, using the building and expending energy to keep it warm or cool or ventilated or lit or something. But moving along with this, the most of the time people really focus on this upfront part, so the part on the left-hand side of the blue square, and that's really where a lot of this goes. And we don't usually have as much influence over what happens at the end of the life of the building, so we can make assumptions about that. But it really ends up being pretty critical to think about that and to ensure that when we're designing buildings, we are taking that into account, that we should be thinking about what's going to happen in the future. So we're creating the opportunity for disposing or reusing our buildings in a manner that's going to have the best impact. Yeah, so actually that's upfront piece, the extraction and manufacturing, kind of the cradle to gate area is really where a lot of the accounting for embodied carbon typically goes, and that's not bad. Clearly, the right-hand side is important as well, but the left-hand side is kind of the part where we can focus on today. The other thing about embodied carbon is it all happens like right away, right? So we have these yellow bars here are indicating embodied carbon, the middle one being kind of repair or renovation that might happen to the building. But all of that stuff adds up, and the blue bars are indicating operational energy. But what this means is that, this is a big hit of carbon to our climate right up front. And, over the course of 30 years or so, that embodied carbon will be sort of met by the operational carbon. And obviously, if it's a more efficient building, it might take a little longer, it might be a little less, but the embodied carbon is huge. It's equivalent, considered equivalent, over the, say, a 30-year lifetime. And that's, it's worth thinking about, how can we start to address this? So I guess maybe, kind of the good news here is that because people have not been thinking about embodied carbon too much, there's really a lot of fairly straightforward ways of addressing this that we can get on right away. So how do we do this cost effectively? Well, this was a question that we had at RMI, and a few years ago we worked with Skanska, and we produced a few reports. There's this solutions guide for concrete obviously being one of the big concerns, and then we looked at overall building construction and how can we kind of start to think about reducing embodied carbon, and what makes sense, what's cost effective or at cost parity. So we looked at 3 different building types, and these were real buildings, actual physical buildings constructed by Skanska. And we looked through all of their different materials lists, and we took three kind of typologies that we thought were kind of representative of a lot of buildings out there. They're all sort of slightly different. We've got the larger steel reinforced concrete building, a wood frame building, and a tilt-up building. It's more representative of warehouses. And with all these building types, we were able to look at basically material substitution. So just one-for-one material substitutions, going from what was actually spec'd in the buildings that got built. And then if we went to something that was sort of best of class or available for that building, but at cost parity. So, in this case, with the mid-rise concrete and steel construction, if we found another kind of concrete that was a lower embodied carbon and was essentially the same price, we just plug that into our EC3 calculator in this case, and we looked at all of these different areas, and we're able to come up with something in the range of a 45% reduction in carbon. And this is just, again, cradle to gate, A1 to A3. And saving in the range of, 2,000 tons of CO2e. And you can see in this case, this, it's a concrete building. So concrete ends up being kind of the lion's share of the savings, but there's still quite a bit of savings in steel and glazing and other things along the way. So it's one of those games we play where sometimes you can have a little bit of savings in a lot of materials and get to a good reduction. And sometimes it really just makes sense to focus on the big, the big issues. So that was this first one. And just as comparison with this wood frame building, concrete is still important because it's got so much darn CO2 associated with it. But insulation was critical here, right? Because in this wood frame building, a lot of insulation there. By substituting a very low embodied carbon insulation for what had been originally specified, we're able to bring that down, 16%. Fantastic. And again, essentially no impact on the budget. This, half of 1% is really in the noise. If you've ever done some costing for a building, it's, so this is kind of made the point that we're trying to make, which is that there are a lot of significant embodied carbon reductions that are available to a typical project, essentially simply by asking and specifying them. It's not, this is not a big deal. This is where we are in the position of it hasn't really been thought about that much to date, and so people haven't really focused on it. And us as professionals in the construction industry can just say, hey, let's ask about this. Let's check the environmental product declarations, and hey, we can actually have a big impact fairly easily. Now, obviously, it varies a lot from location to location, but if you don't look, you won't find it. So how do we think about that in terms of kind of the measurement or the amount of embodied carbon in a building? There's two pathways here, and they're both useful for different aspects. The one way is to think about it on a kind of material by material basis, and it's usually thought about from the environmental product declarations, or EPDs. And then the second way to think about it is from a whole building basis, right? So this awful acronym of WBLCA, whole building life cycle assessment, which allows us to kind of do trade-offs between different materials. And so this is two different ways that have different kind of attributes, and both actually very useful for different reasons. But the EPDs are becoming quite standardized. I think they're becoming increasingly competent and able to be used with a fair degree of confidence and validity and comparability. So it's kind of cool that we have some good rigor on those. With the whole building life cycle assessment, I'm going to say that it is evolving. It's still sometimes a bit more complicated. It's a bit more, there are different baselines that people use. So the results do vary more than they do with the EPDs, which are, like I said, a little bit more carefully curated in terms of their accuracy. Okay, those are the two big ways of doing it. EPDs in general, it's like I talked about with the little Skanska study. You can do a material by material switch out. You can basically take two kinds of flooring. You can take two kinds of wallboard. You can take, two kinds of glazing or whatever it is, and look at them and sort of say, okay, this one's going to have a lower environmental impact, or this one's, it's pretty straightforward. The whole building approach allows you to kind of really switch out whole materials, right? So you can start to think about what would be that impact of steel to wood, or what have you. You can really do a bit more And that's not really something that you can do with an environmental product declaration. So this is a really significant way of thinking about this differently. And this actually has a subtext, which is that to get really deep energy embodied carbon savings, you kind of end up needing to do the whole building LCA. And that's where it's a little bit, like I said, a little bit more nascent in terms of the development of these tools and baselines and such. But in the end, when we're thinking about policy and so forth, we imagine that this is going to get a lot easier in the next few years. And as it becomes more integrated into policy and things like that, we will see those deeper savings that are really only available by thinking about it more integrated as a holistic way rather than material by material. But right now, it's really easy to go ahead and do material by material, and there's no reason why you shouldn't. It's something you can do today. So let's talk a little bit about strategies. My friend Larry Strain, I wish I had a better photograph of him, but he's a very nice guy, put together these 10 points, and this is available on the AIA website as well. He got kind of a fair amount of traction with this little article that he wrote, and it kind of sort of, it points to some fairly obvious things. It's not the last word here, but it's kind of shows that there's fairly straightforward ideas here that we can do and we should do. So reusing buildings, dealing with concrete, limiting these carbon intensive materials, using EPDs to choose, lower carbon intensive materials in different areas. Think about carbon sequestration in materials, and we'll talk more about that. Used materials, reused materials, high recycled content. Thinking about structural issues. How can we kind of be more efficient in our use of materials through kind of clever structural ideas? And just minimizing the amount of materials that are in there. So these are all kind of self-evident, but they do add up to significant pieces here. And I guess as architects and designers here and engineers, I'm going to say that this is something you should not be afraid of. This is actually something that is straight in your wheelhouse, right? These are not scary. This is actually your opportunity to show how clever you are and to kind of think about design, right? Think about how this can be actually part of your palette, moving through the process of optimizing and building and being really excited about, design issues. This is not, it can be just specification, but it can be so much more. So an example of this is your sort of local hero down there in Atlanta, the Candida building, really beautiful building. I think it's very pleasant interior, a lot of timber, and also I think the material is used quite efficiently, right? So we've got a nice combination of steel and wood to kind of identify ways that you can kind of strategically think about tension as opposed to compression and things like that. And there's not, overall, it's done quite effectively and efficiently. And it has quite a, like over 40% reduction in CO2. So that's impressive. This is a good building to be proud of here. And it's beautiful. And I think in this case, you can sort of see how low embodied carbon as a design influence assisted with kind of the integrity of this project. So good work, LAS and company. So thinking about this sort of design aspect, there's sort of things that are going to happen right up front, and then there's things that are going to happen kind of at the end of the process here. And, right up front, we can start to think about this more a holistic approach. Are there opportunities for using existing buildings? What are those kind of larger design ideas that you can do in terms of location and concept and, all of those things that can actually have the biggest impact in terms of CO2 reductions? And then on the other side, we have, what we did actually with that Skanska project. Still got incredible high amounts of CO2 reduction, but it was really just by substituting material for material. So there's a continuum here of ability to have influence of how you would like to, wherever you are in the design process, have those impacts. Makes sense to also, I think, always identify what are the big boulders or rocks in the stream, right? So up here, we've got on the left-hand side, steel and concrete, insulation. These things are almost always issues, right? And buildings use a lot of materials, right? That's kind of what they're about. So we do need to be concerned about all of these other smaller bars, but really it's that upfront kind of material that is as concrete and steel that if you don't recognize them right off the bat, you're missing kind of a big opportunity. This is from a federal building analysis, so that's just a little caveat. You know, again, as always, your results may vary. So concrete, a couple of ways that you can just start to think about it. Performance specs is really good. And this is to some degree empowering your engineers about how to do this. And there is, you know, the SE50, Structural Engineers 2050, that are actually coming up with ways of thinking about this that is really useful for, you know, design. So thinking about it from a performance-oriented way rather than necessarily just a prescriptive. Thinking about SCMs. Now, these are a wide variety. People have traditionally used fly ash. That was something in lead, but there's also slag from steel making. There's rice husks. Now, people are starting to use other pozzolans like ground glass. There's all kinds of SCMs out there. Oftentimes, they can be actually improve the performance of your material. Not always, not to, you know, all of the, every project has different criteria, but think about it. SCMs. Monitor how the project is actually going forward. Using sensors to see how concrete is setting up can make a huge difference in terms of time, money, and materials. Concrete recycling is becoming more and more so. Difficult sometimes because obviously it's a heavy product and usually it's only really appropriate when you're going short distances. So if you're taking down a building and then being able to reuse some of that material. And then this idea of actually trying to use sequestration within concrete. So there's different sorts of aggregates that can have basically, you know, CO2 in them that can be injected, or you can actually create different materials that are put into the concrete. That's really interesting. And then, of course, just how efficiently it's made. There's the newer kilns with, you know, greener electricity or sources can make a lot of difference in terms of the CO2 embedded in the creation of the cement and the concrete. So all of those different pieces, the aggregates, the cement, the distance, lots of opportunities for seeing how you can reduce it. And again, it's typically one of the largest areas where you see embodied carbon being, it's one of the large areas. Here's an example of a building in Washington State, just again, by specifying a lower embodied carbon concrete, they're able to save about 30% of the CO2 in this building. I would like to say that it changed the look of the building, but the building is just nice looking anyway. Steel, obviously, another important product. There's a lot to say about this. Steel is changing a lot at this time. Sometimes it's opportunistic to basically just be using high recycled content. There's a big difference between the kinds of ways steel is manufactured. And I think we're going to see a lot more kind of development of green steel as we're going forward here. Really, really interesting area. And I think for us right now, it's mostly about recycled content here in the US. Wood is kind of, some people would like to say, oh, we made a mass timber building and so we're good. And it's not quite that easy, unfortunately. While in general, wood tends to be a much lower embodied carbon product, and to some degree, wood can actually be, will sequester carbon. It can have, more carbon in it than, it removes a lot from the atmosphere. But it can also be pretty environmentally destructive. And, the kind of idea here is you've got a growing tree that's already up there sequestering carbon, and you're going to cut it down, and that's like an improvement. Well, so the interesting part about this, and it falls into a kind of a larger description of biological materials, is time ends up being a critical component with materials. If a tree is 70 years old and it's the end of its useful life, in terms of it's not going to live much longer, it may have kind of gotten to the end of its ability to sequester significant amounts of carbon. And if it has been carefully forested and it's, using FSC or some other sorts of kind of reasonable forestry area ways of thinking about things, that can be a really great opportunity. But it's not, like I said, a shoe-in. You really actually have to look very closely at where things are coming from, the transportation, the care of the farmers.
Like, what's a mystical experience, Mike?
So, yeah, it's not, it's kind of complicated. And I think you'll see this when you start to look at this in more depth. But in general, we like wood. What's even better is more rapidly growing materials that are done, on a short-term basis that can be sequestering carbon and then stored. So that's I think where we're going with a lot of the impact in terms of building sequestering carbon. Obviously, reusing buildings is a huge opportunity. We've talked about this a lot. Not always the sorts of things that people think about, but it really does have a huge difference. And there are some great examples. Edith Green is a pretty cool building, about half the amount of embodied carbon as a new building would have been for this. A lot of the, carbon is in the structure, in the foundations, and the structural elements of the building. And so to the degree that ends up being reused, that ends up being a huge environmental savings. There's this really cool project in Denver, which is they took this, windowless box of a warehouse and turned it into this really nice new building by kind of integrating, old part of the old building and the new building. And again, a lot of CO2 saved in that process. So there's it's kind of a creative design thing about how we reuse and kind of imagine this. And I really like the idea of embodied carbon helping us think creatively about some of these opportunities. So it turns out, as you know, that this is just a huge thing. And from a residential perspective, we've done this recent publication, which is looking at it from, statistically, what does this look like? And this is a study that Builders for Climate Action out of Canada did with some other help. And you can see these benchmarks where we've got a high embodied carbon emissions in red, those red dots, and the lows in the blue dots. You can see that some are significantly below zero and negative 500. That's just an enormous way of sequestering carbon, but that's an outliner. Most of them are kind of in the 70s or the 130s. That's the sort of low end, which is really great. And as an average, it's about 180 kilograms of CO2 per square meter. And so if you take that 184 and you multiply it by the amount of square footage that's happening in the United States on an annual basis, we're getting up into the range of 26 to 39 megatons of carbon per year that's being created by these buildings. So this is and residential buildings actually are also one of the ones that are easiest to think about it from a lowering their carbon impact or creating carbon sequestration within these buildings. So here's that opportunity. And we'll talk more about that. What we're talking about really is going from kind of where we are now, and I'm going to show this graph like 3 more times in different ways. So I hope you like it. But the idea here is that, we're kind of in this place where we're trying to drive down our emissions, right? And it's operational emissions, but it's also embodied carbon emissions. But if we just get to 0, we've still got all that emissions here, right? So we really need to get into this blue zone, right? We need to actually get into negative emissions, basically by storing carbon in buildings. There's other ways of doing it, of course, but negative emissions. And I would have 15 years ago really been skeptical that this is actually a significant, valid, calculable part of our architectural practice, but it is. And I am convinced, and we have examples, and it can be done. And so we have this opportunity to actually become a significant part of the solution by thinking about negative emissions in buildings. My friend Chris Magwood kind of identifies 5, and again, great photograph, right? This is why I don't put photographs of myself up there. So Chris kind of identifies 5 different areas of thinking about biological materials for sequestration. And we also talk a lot about carbonates and other ways of kind of crystallizing CO2 into cements and other things. And that's very durable as well. But the biological stuff is super easy and available now. So there's waste stream fibers, and this is where kind of your different sorts of cellulose insulations and other kinds of, paper, textiles, those kinds of things happen. Those are great. Agricultural residues, I think, we like to think of this as probably one of the biggest opportunities right now, because it would help in 2 ways. It's one thing, this is like, the straw after you're, removing the wheat, you have all of this fiber left. And typically this would actually go back into the atmosphere, as it decomposes. We can take that, turn it into a building material, insulative, and store it for, whatever it is, 50 years, 60 years. And that, so it not only does it not go back to the atmosphere, but it actually gets renewed on an annual basis, right? This is a 1-year kind of time frame for storing carbon, as opposed to, say, timber, which is going to be in that 70-year or so time frame. So these agriculture residues, straw, rice husks, all of those kinds of things are really interesting opportunities, because we tend to be making them anyway. And this is actually kind of integrating that agricultural and our kind of architectural or, real estate moves together. And then there's a bunch of other things. There's, these purpose-grown crops, and there's nothing wrong with, these. They're good, but it's basically just, making those materials specifically for insulation or what have you. There's different kinds of lab-grown materials, and these are really exciting, but they tend to be a little bit on the exotic side and not as available. And then there's, of course, timber, which we've spoken about as well. So a bunch of different ways of thinking about biological carbon storage in buildings. Here's a building, actually, that Chris was the architect for, and it's in Canada. And basically, you can see in the base case, there's about 500 kilograms of CO2e per square meter. As it's built, it's around 60, so enormously less. And then if you think about it in terms of the carbon sequestration within the wood that it was built out of, it's slightly negative, in the range of 16 kilograms of CO2e. So net zero operations, net zero building materials, sounds pretty good. But of course, we can't stay there, right? We have to do better. So, and a lot of these material substitutions are pretty straightforward. A lot of you may have seen Glavel, and then these different insulations. Wood siding is a big deal. Lower embodied carbon concrete. So from that, we can actually start to think about what is the next step. And this is, again, a smaller house, but it produces more energy than it uses, and it actually has a significantly negative carbon storage. More than that, it's actually designed to be disassembled and reassembled, and it has been disassembled and reassembled. So it's kind of taking advantage of where do these seams come together, and making seams part of the design and things like that. And it's done at cost parity. So it's pretty cool that you can actually now even go further, right? These buildings are now power plants, right? They're sequestering carbon, they're producing electricity. Yeah, I don't know if this is a living building that gets up and moves, I guess. I don't know. So here's the building. Actually, you can see it's put together in these modules, and then it's actually able to be disassembled and reassembled. And, this can be done at scale. Again, 20 years ago, if you were going to tell me I could do a 60,000 square foot office building, or school with straw bale, I would have been skeptical, but here we go, right? And so this is something that's not only possible, it's oftentimes very cost effective to do these sorts of things. So we can really start to get significant carbon storage when we start to integrate these biological materials at scale. It doesn't have to be the building, it could be a series of buildings, right? So here we've got a development in Wales, and they about 30 tons of CO2 per dwelling. And I think there's about 30 dwellings here that they've done. So again, avoid the carbon intensive materials, use the carbon sequestering materials. You can actually get over that balance into a significant amount of carbon sequestration storage. So avoiding these red things, we have the information now. We don't have perfect information, but we have good enough information to make really good choices to avoid these carbon intensive materials as much as possible, and then start to really employ some of these negative carbon materials and start to play that game. It wasn't that long ago that, to have a net zero energy building, people would be thinking it was, some kind of exotic thing. And I suppose it's still not super common, but it's definitely something that people realize is possible, like an electric car. Well, we're at that point now, I think, with carbon storage in buildings. There's all these interesting products coming out, panelized things, different kinds of insulation that are bio-based, just exciting, interesting, weird stuff, everything from, growing your concrete to, having net zero steel to, carbon negative Portland cement, just all kinds of interesting things that people are doing. It's a very fast growing area. And there's carbon sequestering areas as well. So it's not just low embodied carbon, but like I said, there are ones that people are looking at for going beyond low to negative. So that's the way that we get from this, current average of buildings, reducing them, and we're hoping to get aligned with IPCC to get to net zero and get to carbon storage as a, kind of as a regular sort of normal course of events within the next, 15 years or so. And it's not impossible. I mean, we got to, little whatever wooden I-beams pretty quickly. I think we can do this as well. And we also did a study for the GSA, General Services Administration, with their portfolio. And we gave them a bunch of different policies to start to think about how they could think about their portfolio as it grows. And if we have business as usual, you've got this dark line at the top. Then you've got, basically a little bit more smart planning, gives you kind of the slightly lower blue line. And then we can start to think about, buy clean type targets. So basically coming up with specifications around the amount of CO2 that's being specified in or allowed in a given project. And then the bottom green line, I think is worth noting, and I mentioned this earlier, once you start to think about things in terms of a whole building LCA, then you can start to really get higher levels of performance out of these products. And that's key to getting below zero and actually encouraging kind of this performance basis from our engineers, from our people that are procuring these products, as well as us as designers. So this is about us. This is about what we're doing, how we're doing it. I think I hopefully have told you that a lot of this is done either at cost parity, or it can be done with the financial implications less than a lot of the other material specifications that we put in for countertops or other sorts of wonderful things. And what we're doing really is we're making better buildings. That's the goal here, right? We want these things to support the life that we want. Having low embodied carbon is great for kind of recognizing the value of these buildings in terms of their ESG and climate commitments. Potentially, there could be something in carbon credit markets, and we talk about this quite a bit. And those of you who have kind of put your toe in this, it's a little bit, let's say it's evolving. It's not a clear thing that, there's X amount of dollars that's associated with the ton of carbon, and it's clear across the board, like, the US Treasury. This is something that varies a lot, but it is coming. There's some areas where carbon credits can be traded with a lot of security and legitimacy, but that shouldn't be the thing that is determining this. But I would be remiss if I didn't say that I think it's coming. As I mentioned, this can be done essentially at the same cost, and sometimes actually at less cost, right? This low embodied carbon can be, these materials, they're multidimensional in terms of their different qualities, right? We're not just trying to optimize on one criteria. We're thinking about color, we're thinking about strength, with the setup time, prefabrication. There's all these different aspects to low embodied carbon, which we can take advantage of to be either at parity or even at reduced cost. So that's a real benefit that we should be thinking about. There will be policies and codes that come up this way, but really the thing that is hopefully most important is that we are able to increase the value of these assets. A while ago, when you had a LEED gold building, that was required. And I think to a large degree still, people in the real estate industry look at gray or, brown buildings as opposed to green buildings. There's value to having good interior air quality, to having low utility costs. Well, I think that having a low embodied carbon is also going to be perceived as an increase in the asset value. And so when you do this for a client, you are helping them, you're taking your architectural design knowledge and you are applying it to create a better product for that customer. And that's huge, right? That's what we should be doing. Oh, and yeah, there are environmental benefits too. Okay, so a lot of you have probably seen the Architecture 2030 graph here. You know what the issue is. We have to do this. I mean, hopefully what I've said today is that, you want to do it for a lot of different reasons. The other thing is we really need to do it, right? It's critical. It's not the only thing. We still need to think about how we interface with utilities. We have grid connected buildings. How do we get to, zero operational energy? But low embodied carbon, it's happening now. It's right up front. and it can help us do a lot to get there sooner. So that's what I have to say. And I will also say we have a lot of tools and resources out there on RMI's website, but also a lot of our friends. New Buildings Institute is having this Getting to Zero forum in a few weeks in Minneapolis. There's the tools, EC3, the Beam, Epic, a million other kind of tools out there that are free that can help you. Carbon Leadership Forum has got a great amount of information on their website. So you have all of this stuff in your quiver to apply to your next project. And I guess with that, I am going to perhaps stop sharing and ask for questions.
All right. Well, thank you so much, Victor. We do have a few questions here in the chat. And our first question comes from Paul Minardo. We actually had Bill McKibben speak here about 6 months ago, and he was saying that on the related topic of global warming, that we know a lot from going back a generation or so ago, but then we lamented about how poorly we're dealing with it as a nation and as a world. And in your perspective, do you think we're making significant headway?
You mean, am I an optimist?
Yes.
Yeah, I think I saw that Bill McKibben talk or heard that. And, one of the things that at least I remember from that was his focus on investment and this idea of, we need to put our money where our priorities are. And so that's actually quite a big focus of what we're doing right now at RMI. We think about policy and trying to get people to actually require or encourage low-embodied carbon materials. We think about the technology like all of this biological sequestration stuff and those products, and how do we train people to do that. And then we also think a lot about investment. And one of the next products that we're going to be coming out with is an investment guide for low-embodied carbon buildings. Because we think that really putting your money, shifting where your money is going into the direction where we want the industry to go is going to help, right? And so from that perspective, I would say, yes, I am an optimist, because I do see these huge, Ernst & Young is assessing ESG stuff. It's no matter how much kind of rabble rousing you might hear on TV and stuff, this is happening. It's definitely happening. There's a lot of people that are concerned about social justice, and that is a huge investment area. The money is moving towards investing in these products and into things which are encouraging our environmental benefits. So it's really that idea of, the arc of justice is long and perhaps warped and torturous, but I do think we are actually going to get there. So
Great.
I really appreciate Bill McKibben, but I got to tell you, yeah, and I wish it was already happened and I could retire and say, yeah, I remember when we used to worry about global warming. Well, it's going to take a little bit longer, but I think with all of us on, it'll happen.
Do you think we're at the top of that curve and we're actually starting that downward trend to get towards net zero, or what's your thoughts on kind of where we're at there?
Yeah, so good question. And that's in some ways, it's a data question. I think a few years ago, buildings had a larger share of the energy and pollution pie than transportation. And I think transportation has overcome that. And I'm not quite sure if that's just more cars or it's actually reduced energy in buildings. But I think for sure, when we look at things like CBEX, which is the commercial building, help me out, Howard. There we go. Yes. So, that's going to, that's coming down. Actually, the amount of energy per square foot that our buildings are using is coming down. Now, is that commensurate with the amount that we're building? It's a little bit of a question. I do think we are heading in the right direction. I think we are at the top of that curve and we're coming down. Yeah.
And Josh Plord here had a question about voluntary versus compliance market incentives. And Josh, if you would like to just unmute yourself and feel free to.
Yes, thank you, Paul. Hi, Victor. How are you?
Good.
Josh with Neighbor. Yeah, I think sometimes the green premium is a perception. I would agree with that. So it depends on the case. Sometimes it's a perception and sometimes it's actually real. And so I think one of the major topics of our time is how do we accelerate decarbonization by providing new financial pathways that we haven't had before to enable emerging solutions such as straw and some of the other great ideas that you mentioned, enable that to become the new convention. Because really we need new conventions of how to get our embodied carbon as low as possible. So my question for you is, there's a couple of pathways that we can potentially go down. One being the voluntary markets, perhaps creating offsets, using buildings as carbon sinks and creating offsets, such as the work that Arias Earth is doing with their derivative that I'm sure you're familiar with. And then the other one would be like leaning further into policy and trying to create essentially legislation and mandates around targets that successfully get more and more robust as we go along. And I guess I'm curious to hear from your point of view, do you see one or the other being more or less effective?
Yeah. Yeah, so it's a great question. I mean, it kind of goes to what are the levers of change that we have? What's the theory behind kind of our actions and how can we have the impact that we want? My kind of the simple-minded thing is we need it all, right? We need the bigger picture is there. I think Paul might have said something about perverse incentives, and I think there are a lot of those right now. And so I think, like, why the heck are we continuing to subsidize fossil fuels, right? I mean, that's just wrong on every level. But I think that we can do a couple things, which is the market is just, it's not perfect, right? If the market really helped us do everything that we needed to do, then we would be living in a paradise, right? When we wouldn't have whatever, so many issues. But the truth is that there's a lot of disincentives. There's things that are externalities that people don't take into account when they're making money. They're basically, displacing other kinds of benefits. So I think we need to have policy as well, which to a large degree can help steer a lot of our market issues. And to the degree that we can start to be creative with that, there was recently a policy that was passed in New York, New Jersey called LECLA. I don't know if you are familiar with that, but it's these acronyms are going to kill me. Low embodied concrete and cement something act. Anyway, the idea is that not only do they want to have a low embodied carbon cement that would be purchased by the public sector, but also if you go beyond that, if you have a increase or you're exceeding that benefit, then they get a proportional kind of incentives to do that. I think tax incentives. So it's kind of cool, right? So what you're doing is you're creating within a policy something that's helping move the market in the direction that you want it to go. So, it's I think we have a long ways to go here because of the way that we are here in the United States. There's certainly places where this is not quite as mixed up, but hopefully we can use both. I guess the wrong thing, at least from my perspective, even though I'm not a great fan of market forces, I know enough that you can't really fight it, right? I mean, it's kind of like, apple pie or something. You can't say you're against that. So let's try and see if we can have policies that are going to encourage market forces to go in the directions that we want them to go. And I think that there's actually a lot of opportunity there. there's a lot of, business opportunity in having good policies. And so I think we just need to kind of basically win the hearts and minds on that battle.
It seems like there's a lot of policies coming up at kind of more either at the state or local level, like you mentioned LECLA, and I know it's some other states, or in New York, and some other states like Colorado, and then I think Marion County has one on embodied carbon.
Yeah.
But the next question was from Howard Wertheimer, and was asking about what your thoughts on national policies are related to establishing carbon footprint goals for new and renovated buildings, and maybe same for EUI, like any operational emission policies.
Yeah. Yeah. Nice to see, Howard, you're here, and other friends on board. Need to get back to Atlanta sometime soon. We work a lot at the federal level. I used to sit on the Green Building Advisory Committee, and that was where we first started to get some kind of buy clean type of work being done at that level. And that was well reinforced by the IRA, the Inflation Reduction Act, and all of the funding and incentives that came along with that. So definitely moving, the federal group, and the GSA is huge in terms of its footprint. Moving them helps move the market, right? Because once they start demanding stuff, other people do as well. Similarly, we have been working with the Department of Defense. They're under a federal mandate to get to have all their DoD facilities be net zero by, I think, 2035. It's huge, right? That's even bigger than the GSA. What's bigger? I don't know, DoD. So after that, so that's going to move the market too. So the federal government definitely has a role there. Last thing I'll say on that is that the third area is we've been working with the Department of Transportation, which also uses a heck of a lot of materials. And there's a sort of an interesting relationship between what happens at the DOT federally and then the local state DOTs, which tend to emulate a lot of the similar policies. And so we see things come up from the state to the federal or to the higher level, and then oftentimes things will come the other direction from the federal level, influence state or city level. So we think we need to operate those policies at all those levels as much as we can.
Great. And I know that the time it's 12, just after 12:45, and want to be respectful of yours and everyone else's time. Do we have time for one or two more questions?
I would like to follow up with this chance.
Yeah, or if we could, would
Sure.
there be a way that we could get in touch with you if we had other questions that we wanted to?
Yeah, Paul, if you don't mind, just forwarding questions to me. I'm glad to stick around for another 5 minutes or so. But then also go ahead and I can answer some more of these questions, through email or something.
Okay, fantastic. So there was another question about the use of agricultural products and buildings, and you had mentioned you had listed about 5 of them, with the timber being the one that we all kind of know very well. Are there some really kind of clear, no-brainer agricultural products we can use now with the tech we have, or do we need to do something special and the tech's not there yet to incorporate some of these? Like what?
Yeah, so I think that's a little bit of a regional specific issue. So for example, I think in the Northeast, there's a lot being done with wood waste, right? So that's pretty exciting actually to see people manufacturing insulation products and boards out of scrap wood that's able to be reused. There is a lot of straw bale stuff happening, and that industry is really well developed in, say, California and a few other places. And more of these prefabricated products are becoming available where you can actually have essentially panels that you can, put together in a modular fashion. So there's quite a few of those available. It tends to be a little bit regional. I don't know if that really answers the question. It kind of takes a little bit of effort to kind of go in and see what products are available. And and like interface carpet. It's not an agricultural product, but you can get that, carbon negative carpet backing, and you just have to look around, really.
And maybe a last question here actually comes from our chair, Francis Hamilton. So I'm an architect doing a sustainable site project on landscape, and I was under the impression that embodying carbon in trees, plants was good. Could this be expanded upon in buildings? So if you're designing a building and you have a good amount of landscape as part of that in the master plan, what are the things we can do there, like with planting a forest of trees, say, help as part of your project that you're developing, whether it's an office park or a community, mixed use community that has a good sized landscape component with it?
So yeah, this is a great question to sort of, if we end on. We are all dependent on the biological world, essentially, right? It comes down to ecosystem services that are produced by all of these ecosystems around us. The water is being cleansed by, going through different kinds of aeration and through biological things. And for sure, landscape is primary. There are some good programs right now. I can't remember the name. It's on Architecture 2030's website, but there's a climate program where you can actually identify how much sequestration is happening by different kinds of landscapes. And if you switch out one product for another, how that affects it. But for sure, you can quite simply look at a product. Let's say this house that I'm in right now, which is actually not this picture, but my house, we ended up doing renovations and using quite a bit of embodied carbon to do that. I could see that by having a green roof and doing various things to the landscape, I could improve the productivity of the landscape and sequester that carbon in, I think it was about 15 years, right, that I could actually do that. So for sure, it's primary. I'm much more enthusiastic about doing things within the site that you control rather than doing it in a rainforest in Brazil. But certainly having landscape be included in the building design is critical to actually getting to the sustainability goals that we need to get to in the long run.
Great. Well, with that, thank you so much. And just to let everybody know, the recording will be made available on the AIA Atlanta COTE website, and that should be up within a week or two. And please feel free to follow up with me with any questions, and I'll pass those along, and we'll try to get those answered for you. So thank you very much, Victor, and everybody for attending today. Thank you.
Yeah, thank you for your time, and go get to work.
Yeah. Please.
Thanks so much, Victor.
Yeah. Take care.
All right. Take care, everybody.